Fire moves astonishingly fast. In less than 30 seconds, a small flame on a desk can grow into a major, uncontainable hazard. That means the moment a fire starts is not the time to start reading manuals. We are going to walk through exactly how to quickly assess a fire, classify its fuel source, and select the precise extinguisher to stop it. Keep in mind, portable extinguishers are tools meant to work alongside your building's primary safety systems, like sprinklers and manual fire alarms. Because fire outpaces human decision-making, you have to internalize your response and know your exits well before that alarm ever rings. Your very first move is step 1, the size up. You need to immediately measure the physical scale of the fire. You are looking to confirm if the fire is still in its initial stage, meaning it is small, contained to its fuel source, and manageable with a handheld tool. If the fire is visibly spreading up a wall or across the ceiling, you have passed the point of intervention. Drop the extinguisher and evacuate the building immediately. Portable extinguishers are designed strictly for early intervention, not for battling an established structure fire. If the fire is small enough to fight, move to step 2. Identify the source. Look closely at what specific material is actively burning. The fire triangle illustrates the 3 elements required to trigger combustion. First, a fuel source, solid, liquid, or gas. Second, adequate oxygen. Third, heat or an ignition source. When combined, these 3 lock into a chemical chain reaction that produces a sustained fire. Every fire extinguisher works on the exact same principle, forcibly breaking that chain reaction by removing at least one of those 3 sides. This brings us to step 3, classify the fire. Because different fuels burn differently, fires are separated into 5 distinct classes. In our matrix, Class A fires involve ordinary combustibles like wood and paper. Class B fires are fueled by flammable liquids. Moving along, Class C fires involve energized electrical equipment, and Class D fires occur when combustible metals ignite. Finally, we have Class K fires. These are specific to ignited cooking oils and animal fats. You will almost exclusively encounter Class K hazards in highly specific environments, like commercial restaurant kitchens and cafeterias. Correctly identifying the class of the fire based on its fuel is the mandatory prerequisite before you can safely pick up a suppression tool. Which leads to our final action, step 4, tool selection. Before you pull the pin on any extinguisher, you must read the physical label to verify its classification. Class A extinguishers use water to remove heat. Class B uses dry chemicals to smother oxygen. Class C uses non-conductive agents to prevent electrocution. Class D uses dry powder for burning metals. Class K deploys a soapy foam to suppress cooking grease. Using a mismatched chemical can be life-threatening. For example, spraying water on a grease fire causes an explosive reaction that actively spreads the hazard. The label on the side of the canister is your ultimate authority. If the printed class does not match the burning fuel, do not engage. Now, let's put these 4 steps into practice with a rapid-fire scenario test. You spot smoke coming from a sparking electrical box. You size it up, identify the energized source, and trace it to a Class C extinguisher. Now you see a frying pan fire. You assess the grease fuel and immediately look for a Class K extinguisher. You now possess the analytical framework to safely assess, classify, and react to workplace fires. Your final practical step happens today. Walk through your actual workplace and locate the nearest physical fire extinguisher and read the label. Secure that information now, long before you ever need to use it.